Now we're going to look at another way to generate the same regression analysis results, and that is using data analysis. So go to data analysis and look for regression. So there it is. Okay. Then input Y range. So now we're going to include the label here, so we can check label. Okay, so that's our Y range, sales, and then X range is population. Okay, and then output range, let's put it here. And for now we will not worry about these, we will talk about this in a later video. And again, confidence level, if you want only 95% confidence level, you can leave this blank. But if you want a different confidence level, then you can put a check mark here and then enter whatever you want, like 98% or whatever that other may be. You know, you need to note here that 95% is automatically generated no matter what, and in addition to that, you'll get this different confidence level information as well. Okay, now let's click OK. Then here is the output. Okay, so let's go ahead and format these. Okay, align these. Okay, and significance of F, that's our p-value, so we need to make that into a percentage. And here we'll talk about the confidence interval and so on later on. See here, this is 95% and 98%. If you did not check and enter 98%, instead if you just left it unchecked, 95% will get repeated one more time. Okay. So now we have everything that we computed earlier with formulas are now produced using data analysis. Here, if you look at the coefficients, that gives us the estimate. So intercept is your b sub 0, so 60 plus 5x. So that population here gives us the coefficient for x. Okay. Now the sums of squares, SSR, so that's your regressions sum of squares, and then SSE is residual. So Excel calls it residual. Residual is another name for error. So that's SSE. Now SST is of course that. So you note that these numbers are exactly same as we saw previously, and the mean squares are here. So mean square, that's our MSR, and our MSE is right there. So we'll get to F and other things later on. Now R squared is here. Okay. Now multiple R and other information, we'll get to that in a little bit. Okay, so that squared, R squared. So interpretation of R squared is that 90% of the variation in quarterly sales is explained by the regression with the student population. Interpretation. Now from this we can compute our correlation coefficient. So correlation coefficient is a value between -1 and +1. The sign gives us the direction of correlation, whether it is positively correlated or negatively correlated. And the absolute value gives us how strong the correlation is. So we can get the sign of the correlation, and there is an Excel function called sign. The sign of slope coefficient. So slope coefficient is right here. Okay, so if it is minus, you'll get a -1 here. If it is a positive value, you'll get a +1 with sign. Okay, correlation coefficient then is the sign times square root of R squared, which is right there. Or we can use R squared from here as well. Both are the same. So square root can be the positive square root or a negative square root. and that sign comes from the sign of the slope coefficient. So this is our correlation. And Excel has a function that can generate correlation as well, and that function is CORREL. And now you give the Y range and the X range. Y range is sales, X range is population. Now that will give us the same answer like what we got just now.